welcome to standard 10th geometry. You can see here PS is the median, as S is the midpoint. The sides PQ, PS and PR are given 11, 13 and 17, and we are asked to find QR. So it is very easy. We'll first write that in triangle PQR, PS is the median. Okay, now because PS is the median, we can use Apollonius theorem, correct? Apollonius theorem, PQ square plus PR square is equal to 2PS square plus 2QS square. Okay, this is by Apollonius theorem. Okay, so now PQ you will write 11 square, PR you will write 17 square, 2 PS I'll write 13 square plus 2 QS square as it is. 11 square becomes 121, 17 square becomes 289, 13 square becomes 169, and this will be 2 QS square as it is. Okay, now let us add, what is this? 1 plus 9, 10, 3 plus 8, 11, 2 plus 2, 4. 410 is equal to 169 into 2, 32, 320 plus 18. 320 plus 18 is 338. Okay, plus 2QS square. Now 2QS square is equal to, this will move there, 410 minus 338. Okay, now 2QS square is equal to, what is this? 62 plus 10, 72. Okay, so QS square becomes 72 by 2. So QS square is 36. So how much is QS? QS is 6. Correct? Centimeter, meter is not given, so we'll write only 6. But we are asked to find QR. We got QS, so I'll write QR is equal to twice of QS. Okay, so it is 2 into 6. So how much is QR? QR is equal to 12. Okay, this is how you will do. Then question number 2 is similar, where we have to find median CM. Okay, and you know BC, AC 7, BC 9 and AB is 10. So of course, when there is a median given in a triangle, we can use Apollonius theorem, but here the side on which the median lies, okay, that half portion, the half segment we need. So first we will try to find that in triangle ABC, CM is the median. Therefore, I can write AM is equal to half of AB. Okay, so that becomes half of 10. So how much is AM? AM is 5. Okay, centimeter is not given, so I'll write AM is equal to 5. Now, if you observe, I can use, therefore, by Apollonius theorem, AC square plus BC square is equal to 2CM square plus 2AM square. This is how we can write by Apollonius theorem. Okay, now let us write the values of this. AC square, I'll write 7 square, BC square 9 square, 2CM square. CM square is, we don't know, we have to find, and AM we've just found out, it is 5 square. Okay, so let us solve very easy. 7 square 49 plus 9 square 81 equals to 2 cm square. Cm square as it is plus this will be 2 into 25. This will be 25. So this will become 50. Now let us add this. What is 81 plus 49? 81 plus 49 means I can add 80 plus 50. So it is 130. 2 cm square plus 50. Now this will go there. It will be 130 minus 50. So 2 cm square becomes 130 minus 50 is 80. Okay, now cm square is equal to 80 upon 2 becomes 40. Okay, 80 upon 2 becomes 40. Now because cm is 40, I can write this as root 40. Root 40 is 4 tenza. 4 tenza means I can write 2 root 10. So the value of median cm is 2 root 10. Okay. So coming to question number 3, what we have to prove, I have just taken the first part. Okay, second part we'll be doing after this. So we have to prove PR square equals to this long. Okay, so what we'll do is, first I'll try to take, because PR square if I take by Pythagoras theorem, it will be PT square plus TR square. Okay, so to make the parts of TR square, I'll use TS plus SR. So first I'll take in triangle PTS, angle PTS equals to 90 degree. Therefore PS square is equal to PT square plus TS square by Pythagoras theorem. Okay, now PS square is equal to PT square plus TS square. So this I'll give it as 1, and I'll take in triangle PTR, coming to this I want PR square. So angle PTR equals to 90 degree. So PR square is equal to PT square plus TR square. Okay, this is also by Pythagoras theorem. Okay, now if you see PT square, this is as it is, I am writing plus, instead of TR what can I write? TR is TS plus SR. So TS plus SR the whole square. Okay, so now I have to expand this in A plus B the whole square form. This is in A plus B the whole square form. So A square plus 2AB, correct, into plus B square SR square, correct. See where we are. PT square plus TS square. If you see this, okay, if I make this PT square plus TS square, if you see PT square plus TS square, this is equal to PS square. So I am writing this as PS square, correct, plus 2ST or 2TS. So I am writing this 2ST into SR. SR I am writing QR upon 2. Okay, because it is given that PS is the median, so S is the midpoint. So SR simply means half of QR. SR is half of QR. So I am writing it QR upon 2. Instead of SR I am writing QR upon 2. Again here SR I am writing QR upon 2, but the whole bracket square. Okay, this two changes I have made here. I have written this PT square plus TS square as PS square. So I will write this from 1. Okay, and I have written this SR as QR upon 2. So I'll write S is the midpoint. Okay. Now coming back, if you see, I am here where PS square plus 2ST, I'll just cancel this. I can cancel here 2 and 2. So PS square plus QR into ST. Okay. QR into ST plus QR upon 2 the whole square. Okay. So I am again here. Okay. So we have proved it easily. Okay. Just making two changes here, 1 and 2. So you will achieve this point. Okay. Let us move on to part 2 of the proof. Here we are coming to the reverse triangle PQ square I want. So I'll first write in triangle PQT, angle PTQ equals to 90 degree. Therefore, PQ square is equal to PT square plus TQ square. Okay. Now this is of course by Pythagoras theorem. Okay. Now everything will be the same except TQ. Okay. There also we wrote TR in terms of the median TS plus SR. So here TQ if you see will be QS minus TS. I want to write TQ in terms of the median. TQ is the segment which is QS minus TS. Okay, so it is QS minus TS the whole square. Correct? Now let us expand this. This is in the form A minus B the whole square. So I'll write A square minus 2AB. Correct? Plus B square. B square is ST square. Okay. Now let us try to match this. See, PT square plus QS square. PT square plus QS square. Okay. So this, if you see, I can take this as PT square plus QS square I am not getting. So PT square plus ST square if I take. PT square plus ST square will become what? PS square. This is from point number 1. In point number 1 we wrote. Okay. Now whatever remains I'll write down. Okay. So now this is. So I'll just write this first, minus 2QS into TS. This I'll write in the end plus QS square, because this is how we want to write. Okay, PS square minus 2. This is QS. QS I will write SR. Beg your pardon. QS I'll write QR upon 2. QS is half of QR. Okay, into TS I'll write ST, one and the same, plus QS I can write QR upon 2. So we are very close now. What we want, what is the difference? Only if we cancel 2 we'll get to it. PS square minus QR into ST plus QR upon 2 the whole square. So only one change we did here. Okay, so this is what from 1. Okay, rest this is median. Okay, QR upon 2 QS, and this is also QS QR upon 2. Rest it is very easy, but students, this needs practice at least 1 or 2 times. This sum needs practice. Okay, then question number 4, very simple. We are given AB square plus AC square. That means the LHS of Apollonius theorem. we are already given. Okay, and AM also we know, AM is the median and it is 8. Okay, centimeter is given. Good. So we'll just write in triangle ABC, AM is the median. Okay, therefore I'll write here by Apollonius theorem, AB square plus AC square is equal to 2AM square plus 2BM square. Okay, now LHS is already given. AB square plus AC square is 290. Okay, into 2 into this is 8 square plus 2BM square I'll write as it is. So solving this, 2 into 8 square, I'll do this first and then multiply according to BODMAS. 8 square is 64. 64 into 2 is 128 plus 2BM square. Okay, now 290 minus 128 equals to 2BM square. Okay, now 290 minus 128. What is 290 minus 128? It is 162, correct. 2BM square equals to 162. So what will be BM square equals to? 162 by 2, which is equal to 2 8s are 2 1s are 81. Now because BM square is 81, BM will become 9. Okay, centimeter I can write. Now BM is equal to 9 centimeter, but we are asked to find BC. So therefore BC is equal to twice of BM. Okay, twice of BM. So it is 2 into 9, that is equal to, BC is equal to 18 centimeter. Okay, very easy. So BC we got 18 centimeter. Coming to sum number 5, where we are given a rectangle. PQRS is a rectangle and we have to prove this. Okay, so if you observe this carefully, TS square plus TQ square and RHS is TP square plus TR square. Okay, so if I take this as the LHS of Apollonius theorem and this also as the LHS of Apollonius theorem, so I need a triangle. Okay, so what will I do? I'll draw the diagonals. Okay, the point of intersection is O and I'll join TO. Are you getting? So what I did is, in construction I did join SQ and PR, means I have drawn the diagonals. Okay, now for starting of the proof I'll also join TO. Okay, O is the point of intersection of the diagonals. Okay, now if you see TS square plus TQ square I can get by Apollonius theorem. Okay, so first I know that diagonals of rectangle are congruent. Okay, they are congruent, so I can write PR is equal to QS. Correct, PR is equal to QS. So I can write half PR is equal to half of QS. Why I am doing this? Because the half parts of the diagonals, half PR, I can take SO, half PR I can take say RO, half QS I can take QO. Okay, this I'll simply write multiplying by half Okay, therefore I can simply write all the half parts of rectangles, the diagonals of rectangles are equal. Therefore RO equals to QO equals to SO equals to PO. Okay, all the half parts of the diagonals of a rectangle are congruent. This is from 1. Now let us come here. I want TS square plus TQ square. Okay, you know that O is the midpoint of SQ, so I can call TO as median. Observe only this triangle, children, TSQ. So in triangle TSQ, TO is the median. Okay, therefore I am applying Apollonius theorem here. So TS square plus TQ square is equal to 2TO square plus 2QO square. Correct? This is by Apollonius theorem, and I am giving this as point number 2. 2TO square plus 2QO square. Now coming to this one, I want TP square plus TR square. So which triangle I'll take? I'll take triangle TPR. TPR. Okay, in triangle TPR, TO is the median. Therefore, TP square plus TR square is equal to 2TO square plus 2RO square. Okay, this is also by Apollonius theorem. Okay, Apollonius theorem, and I am giving it point number 3. Still, I can make some changes here. TP square plus TR square is equal to 2TO square plus 2, instead of RO, I can write QO square. Correct? RO and QO are equal to QO square. This is from 1 and 2. Okay. If you observe, what changes I have made? Nothing. 1, 2, 3 are one and the same. Only RO I have written as QO. Okay. Now, if you observe the RHS of point number 4 and 2, what is the RHS? 2TO square plus 2QO square. 2TO square plus 2QO square. That is, RHS is same. Okay. So, I can write LHS also same. So, from 1 and 4, TS square plus TQ square is equal to TP square plus TR square. Okay, we are here, very simple, from 1 and 4. Correct. So with this we complete our practice at 2.2. Goodbye, good luck.